Computer vision is a field of artificial intelligence that enables machines to interpret and understand visual information from the world. By simulating human visual perception, computer vision has revolutionized industries ranging from healthcare to autonomous vehicles and augmented reality. It combines image processing, machine learning, and deep learning techniques to analyze and extract meaningful information from images and videos. Let's explore some core concepts in computer vision. First up, image representation. Images are made up of tiny units called pixels, each containing color or intensity information. We use different color spaces to represent these colors. RGB, with its red, green, and blue channels, is probably the most familiar. Grayscale simplifies things with just a single intensity channel. And then there's HSV, hue, saturation, and value, which offers a more intuitive way to think about color. Resolution, the total number of pixels, determines the image's clarity. Now, let's talk about image processing techniques. Filtering uses special kernels to enhance or suppress certain image features, like sharpening or blurring. A key application of filtering is edge detection, highlighting important boundaries within an image. Algorithms like the Sobel operator and the canny edge detector are commonly used for this. Thresholding converts grayscale images to black and white, or binary, by setting a pixel intensity cutoff. Finally, morphological operations, like dilation and erosion, manipulate these binary images to remove noise or refine shapes. Let's talk about features in images. Feature extraction is all about identifying key attributes or patterns, things like edges, corners, or blobs. Once we've found these features, we need a way to describe them numerically, so we can use them for machine learning. That's where feature descriptors come in. Think of them as a way to encode the features into vectors. Some popular examples are SIFT, or Scale Invariant Feature Transform, SIRF, which stands for Speeded Up Robust Features, and ORB, Oriented Fast and Rotated Brief. Now, on to object detection and segmentation. Object detection is about identifying and locating objects within an image. You might have heard of some popular techniques like YOLO, You Only Look Once, Faster RNN, and SSD, the single-shot multi-box detector. Image segmentation takes things a step further, dividing the entire image into meaningful regions or objects. There are two main types: semantic segmentation, which labels every pixel by its category, like labeling all the car pixels, and instance segmentation, which labels each individual object instance separately, so you can distinguish between different cars in the same image. Deep learning has revolutionized computer vision. At the heart of many modern CV applications are convolutional neural networks, or CNNs. These networks have several key components. Convolutional layers use filters to extract spatial features, like edges and textures. Pooling layers reduce the size of the data, making computations more efficient. Fully connected layers then take these extracted features and perform classification. And activation functions, like ReLU, introduce non-linearity, which is crucial for learning complex patterns. Another important concept is pre-trained models. Models like VGG, ResNet, and Inception have already been trained on massive datasets like ImageNet, which means we can use them right out of the box for many tasks. This leads to transfer learning, where we adapt these pre-trained models to new problems with only a small amount of new training data. It's like having a head start. Finally, let's touch on some advanced architectures. Recurrent neural networks, or RNNs, which we talked about earlier in the context of NLP, can also be used for sequential image data, like video analysis. Generative adversarial networks, or GANs, are fascinating. They can generate incredibly realistic images or even augment existing datasets. And vision transformers, or VT, bring the power of self-attention, which has been so successful in NLP, to image processing tasks.